So when we talk about sun angle, it's really important to note that the highest that the sun can ever be in the sky is 90 degrees perpendicular to the surface of the earth. So this would make a right angle, 90 degrees. This would be the ground surface. Okay, so the highest the sun can ever be in the sky is 90 degrees. If the sun is over here, right, that means that the angle that is created, okay, between the surface is actually less than 90 degrees. Let's say that this is 45 degrees, okay? Let's say that the sun, moves in this direction, okay? Let's say that this would be noon. This is like 3 p.m. This is 12 p.m. Maybe this is, I don't know, 9 a.m. Okay. Let's try it like this. Let's say this is like 30 degrees. I don't know. I'm just making up some numbers here just for visual effect. So we know that the sun is highest in the sky at noontime. Sun rises towards the right of the screen, sets towards the left of the screen. So the highest that the sun can ever be in the sky is 90 degrees. So that's very, very important to know. So then when we talk about how do we calculate the sun angle or the maximum sun angle for our location, it really depends on where is the sun 90 degrees throughout different points of latitude. And then we can use that information to figure out what is our noontime sun angle here on Earth. So interesting story, a couple years ago, my mom actually went to Tahiti on vacation, and she went in September, right around the fall equinox, right around September 21st, 22nd. And when she came back, she was telling me how I wouldn't believe on how strong the sun is. And I said, well, Mom, that makes total sense because Tahiti is located at 17 degrees south. And we know that the equator is right at 0 degrees latitude. So she was pretty much right on the equator or very close to the equator for that time of year. So it makes sense that when she says that the sun was very, very intense, that yes, it was very intense because we know that during the equinoxes, the sun is concentrated over the equator. So when she said that the sun's energy or the sun felt the strongest that she's ever felt in her life, it makes sense because of the time of the year that she was actually in Tahiti was the time of the year that the sun was pretty much concentrated right over the equator. So if I wanted to calculate what the sun angle was for, let's say, Boston, which sits at 42 degrees north latitude, how would I figure out the max solar angle for Boston when the sun was concentrated right around 17 degrees south? Okay, so this is how we use that information. So first of all, we need to figure out what the distance is between the sun and where you are located. So Boston, where I'm located, is 42 degrees north. The sun is located at 17 degrees south. So we need to figure out the difference. Now, when you hear difference, that means subtract. We need to figure out the difference between 42 degrees north and 17 degrees south. So what's very important about this is that you notice that we are in two different units. Here, I'm in northern hemispheric units, but the sun is in southern hemispheric units. And we can't have two different units because that means our math will come out incorrectly. So you need to change one of these units to either all northern hemispheric units or all southern hemispheric units, okay? The easiest thing to do would be to change 17 degrees south to negative 17 degrees north. And that means that now our units are all the same. So if I want to figure out the difference between where I am at 42 degrees north and where the sun is directly overhead, I would have to subtract minus 17.5 degrees north. Well, you remember from basic math that when you have two minus signs, what does that indicate? That's a plus sign, okay? So I'm adding 42 plus 17, which is equal to 59 degrees. So that is the difference between where I am at 42 degrees north and where the sun is at 17 degrees south. So how do I figure out my solar noontime angle for that date? Well, let's say this. If I know that the sun can be highest in the sky and it can only be the highest in the sky at 90 degrees, and I know the difference between where I am and where the sun's concentrated, I simply just have to do some basic subtraction. And so all you have to do is 90 minus 54 degrees, and it comes out to 36 degrees, which would be the noon sun angle for Boston for that date. Now let's say for another example, I wanted to know the difference between where Boston is 42 degrees north and the Tropic of Cancer during June 21st. So let's say I wanted to find out the noontime sun angle for June 21st for Boston, 42 degrees north latitude. Well, on June 21st, I know where the sun is. I know that's the first day of summer. That's the summer solstice. And so I know that the sun is at 23.5 degrees north. Okay, so that's where the sun is directly. So I need to find out the difference, right? Subtract. I need to find out the difference between where I am and where the sun is directly overhead. And so I can easily do this because I'm both in north hemispheric units. So that means I can just go ahead and just do basic subtraction. So 42 minus 23.5 equals 18.5 degrees. So that is the difference between where I am and where the sun is directly overhead. In order to find the noon solar angle, all I have to do is out of 90 degrees, which is the highest that the sun will ever be in the sky, I just subtract that difference from where I am to where the sun is directly overhead, is 71.5 degrees. So that would be the noontime sun angle for Boston for June 21st. And so 71.5 degrees will be the highest that the sun will ever be in the sky for Boston. Okay. Now, obviously, the closer you go towards the poles, the lower that this number will be.